So a couple seconds on my path. I spent a decade in academic physics working with the original big data, which is to say working in fundamental nuclear physics. After academia, I found my way to education technology, first at Disney, where I led engineering for interactive media. We enabled kids to create and share 20 million pieces of art. A big part of that was an AI-based recommendation engine that helped kids connect with other kids creating similar art. After Disney, I went on to co-found WootMath, a startup that built a platform to help kids be pre-algebra ready that was ultimately acquired by Saga Education. One interesting thing we did at WootMath was our use of machine learning, specifically Bayesian-based knowledge models to help students master rational numbers through an adaptive platform. So some of the technologies that Adriana had mentioned earlier. So I'm now at Saga Education along with the rest of the Woot team. Saga delivers best-in-class high-impact tutoring. This is not necessarily what you would think of as tutoring normally. This is done during the school day, and students get to work with the same tutor all year and really build a relationship with someone who cares about their learning. At Saga, I lead a team of engineers that develops Saga's AI-enabled digital platform for helping deliver high-impact tutoring. Now, I'd like to call out the specific areas in which AI has transformed the platform, or is transforming the platform, I should say. We are using it to help identify and train great tutors, to make our personalization more effective, and to enable independent learning, sort of by augmenting skill and drill with an engaging and immersive experience. So today I'll be presenting my thoughts from the perspective of someone who's had a couple of decades trying to integrate the advances from the AI ML community into product for the benefit for our clients, which in this case is students and teachers. So I'm going to switch gears for a bit and talk about generative AI. I was really happy to see some questions about it in chat from a perspective of what's inside the black box, and I'll attempt to answer the question, what is generative AI? So we will start with a description of something that's not quite generative AI. So let's start with an AI application that's been around for a while, and everyone who has a phone is probably pretty familiar with it, which is facial recognition. This is an application of so-called discriminative AI. So discriminative AI answers yes-ish, no-ish type questions, which is to say, is this picture of a face? Yes-ish, the machine might say, yes, that means yes-ish just means yes with a 95% probability. The thing to note here are that there are two inputs to the model. There's first the image, which is a picture of Obama, and the second is the label. Here, the label is face, and the question that the human is asking is this an image of a face? So now let's contrast that with generative AI. So the way that generative AI works is you use a lot of pictures or faces, pictures of faces or cats or whatever, to train a model, in this case, an artificial neural network, to represent very high dimensional input data in terms of a much lower dimensional data. So in this case, the high dimensional input data is the picture on the left, and the lower dimensional data is the set of faces on the right. Now, dimension here literally means the number of numbers you need to use to describe the data. So let's look at the image on the left. There's 256 bits of data per pixel, and there's I'm using my laptop screen as an example. That means that for a typical laptop resolution picture, that's about 200 million pixels, or bits, sorry. So this is what we mean when we say the input data is high dimensional. The right shows a visualization of the representation that the model learns to use to represent this data. This is called, and this is a fancy jargony word that I'm going to have to use again, latent space. But really what you want to take away from that is that the latent space is the model learns to represent a face by taking averages over a collection of faces, and this is what I'm going to call the basis of faces. Now there's a whole lot fewer faces in the basis of faces than 200 million, so it's a much lower dimensional space than the input space. So, so for this example, I'm imagining that there's only two faces we have to worry about in our latent space. And so I'm basically showing that every face can be represented by a pinch of this face and a smidge of that face. So here, the pinch is the number 0.2, and the smidge is the number 0.8. And I can plot these numbers for faces on a 2D graph shown on the left there. And these are the black dots are just the sort of smidge and pinch numbers associated associated with the set of all faces I use to train the network. Now, now that we've done this, well, now we've set all this stuff up, we can actually just pick random points in that 2D space that don't correspond to actual faces and see what kind of face pops out. And let me show you a real example. So the faces in this sort of snap here are not real. They're generated by sampling or picking points from a latent space from a deep neural network. Okay, so this is a really important point to me, and if you take anything away from my talk today, it's that you can understand a lot about the technology without touching the underlying math. And I think this is important because policymakers and decision makers and end users, in our case, teachers and students, can better understand the promise and the limitation of these technologies by sort of taking a peek behind the curtain. Okay, so I've talked about discriminative models and generative models, and now I'd like to talk about another type of generative model called a large language model. So, recent advances in large language models are all over the news. I think ChatGPT has become a household word at this point. So I'm just going to state what large language models are. Large language models are next word predictors. With a starting point that's defined by a prompt, or also known as a context, the model can produce a reasonable continuation. So ChatGPT is currently the most talked about example of a large language model, but they are legion and they are evolving very quickly. Now, here, GPT stands for Generative Pre-training Transformer. The generative is referring to the kind of sampling from a latent space that we just discussed. Pre-training just refers to the fact that this model was trained on a huge pile of text scraped off the web. And Transformer, that's really the algorithmic innovation introduced by Google Brain in 2017. And that is the innovation that in some sense is causing all the fuss. And so, just by way of example, if I say I'm going to the model might come back and say bank, followed by where I intend to deposit my paycheck, and so on. Now, the thing that I want to communicate is that how do you continue the continuation? That is, all you do there is you take the prompt and the word that the model emits, and you feed that back into the model and ask it to produce the next word. It's a really simple feedback loop that lets you generate swaths of believable text. Okay, so on to Saga and the applications of this tech at Saga. A big part of Saga's DNA is the enduring relationship the tutor builds with their student over the course of a school year. So we are using AI to help tutors be better prepared, to be more efficient, and to be pedagogically more effective. So one example of this is our AI-based coaching platform. This is Coaching Tutors. Takes recordings from actual tutoring sessions and is trained to measure what we call conversational dynamics, which is who is speaking for how long. And it's also trained to recognize and suggest pedagogically effective talk moves. This is in collaboration with University of Colorado Boulder and other institutions on the academic side. A simple example of a talk move would be a tutor saying, or a tutor asking a student, can you say more about that? So we're also working on systems to help use generative AI to help content creators quickly generate personalized learning materials. So this could be a tutor who in situ wants to come up with an example because they have a student that's struggling with a particular topic, or it could be a curriculum developer who's working on a learning progression. And I have a fun example of how that all works that I want to share. So chatbot large language models do a much better job when the prompt includes a detailed context. It makes the model's response more relevant and less likely to be wrong. And we will talk about some of the failings of these models in a bit. There's a bunch of fancy machinery that lets you inject custom context into existing models like ChatGPT without retraining the model, which is incredibly expensive. These are called embeddings, but really we can just focus on doctoring up the prompt, which effectively does the same thing. So let's imagine I'm a tutor looking for examples to discuss with a student who loves dinosaurs and is stuck on addition of fractions. The tutor might type, I want an easy problem on fraction addition in the theme of dinosaurs. Now, behind the scenes, the machinery augments that prompt with additional information. It establishes role and expertise by saying you are an experienced and well-educated math tutor. It references official standards, Common Core State Standards for Mathematics. It frames the prompt, prepare the lesson. It requests very specific output, give me an example problem, show the process and its solution. It it's augmented for self-reflection. It asks the GPT to provide a step-by-step way to be sure that we have the right answer. And then this is my favorite part. It requests that math be printed in LaTeX. And LaTeX is a fancy, well, not fancy, but it's a language that's used to mark up mathematics for pretty printing and things like web browsers. So that makes me super happy because I can just take the answer and display it in a pretty math way. And then finally, the prompt itself had some original sort of important context that was injected. The problem is that they want is to be easy, it's to cover fraction addition, and it's to have this thematic theme, dinosaurs. So this is a sort of an example of a way, this new nascent field of prompt engineering, where you get the most out of the models by augmenting the prompts with information that makes the machine more likely to give you the right answer. And of course, the idea is that we're building tools to do this automatically to keep the end user able to present a very simple question and have it be engender a rich response. So I'd like to spend the last couple of minutes or minute enumerating a list of problems with GPT or LLMs in particular. LLMs make things up. I mean, we just talked about sampling from a latent space. You're asking the model to make things up, so that can't come as a surprise. It has toxic and biased content, which is to say it's trained on data that's scraped from the web. So if there's toxic and biased content on the web, then it's going to occasionally spit that out. It has the out of context problem, which is to say, if you run that feedback loop often enough and for long enough, eventually it just kind of wanders off into the ether and you stop getting sensible results, or at least results that are irrelevant to the context that you provided. And finally, this is the opacity of the models is a point that I'd love to just spend epsilon on. No one can claim to understand how the patterns of neural activation and the 200 billion neurons in the brain conspire to produce human language. Coincidentally or not, the largest GPT models have about 100 billion neurons, and understanding the activation patterns that lead to shockingly realistic text sequences is not well understood, in the same way that we don't understand how speech actually forms in the brain. So I'd like to close now with some hope. These are problems, but let me offer a bit of anecdotal data that I gathered from an intrinsically motivated 11th grader who just happens to be my kid. They highlighted the usefulness of the GPT in getting started to essay questions by asking for an outline. They also use it to analyze and check their answers after they've, from a discussion question from a class they're taking online this summer. I find this hopeful, and I don't think it's unusual. And finally, I'm going to leave you with some very biased opinions. I think that knowing the answer is no longer as important as knowing the kinds of questions to ask. The ability to take these sort of encodings of all human knowledge and ask questions of them and critically evaluate the answers is a skill that we will have to teach towards. I think we need to make sure that our tutors and scholars are getting better at getting the most out of these systems without taking the easy path. And I think really a mindset shift where the process, the productive struggle, really that is the value of the exercise of learning, and the results sort of play second fiddle. The human in the loop, I think that's essential. The current models have well-known failings, and humans in the loop can obviate some of them. And finally, ChatGPT large language models are a necessary but not sufficient component of an AI that can truly transform education. It's revolutionary progress for sure, but I don't think the singularity is here. And that's copying a phrase from Ray Kurzweil. Thank you so much for your time.